All right, here we go. Behavior of f of x at a point. All right, you have seen this graph so many god-darn times. Lot to talk about here. Behavior of f of x at a point, we are talking about increasing and decreasing, or we are talking about concavity at a point. Now, if we, you see this, and your first instinct is usually just going to be, oh, I need to take a derivative, right? I see functions, especially polynomials, take a derivative. F prime of x equals 3x squared minus 4, and I can tell I'm probably going to have to do this twice, right? F double prime of x equals 6x. All right. We know we were given this, and we might be asked a question about, is f of x, in this case x cubed minus 4x, increasing and decreasing at a point? Is f of x concave up or concave down at a point? Now, if I just randomly plopped this point down on the graph, call that A. Well, A, really close to this peak right here, you can probably tell me that this point at x equals A, f of x is decreasing, and you would probably say f of x is concave down, just by looking at the graph. Wonderful. And again, this is a graph of f of x. Now, in order to answer the question analytically, so analytically means we need to use the equations. What does that look like? And here I'm just going to say a equals -1. That's probably right about there. You can, hopefully you can tell me, and I'll just graph, based on this. Just go around my a all artistically. This would be my first derivative. We've seen this 1,000 times. I've also told you to learn it. And this would be my second derivative, right? Now, f prime is decreasing, so my second derivative will be negative up until the origin. We've seen this. So if I asked you to tell me about f of x, which is, again, this orange point at x equals a, you would tell me f of x is concave down and decreasing, because you can measure that out. You can also see at this orange dash that my dark blue and light blue graphs are both in the negative quadrant, which confirms, again, we would write something like this. This is the AP style. Ready? What color do I want to write this? Let's write it in red. F of x is decreasing at x equals -1 because f prime of -1 is less than 0 and f of x is concave down at x equals -1 because, I'm just going to do b/c, f double prime of -1 is less than 0. Very easy to see. And on an AP test, keep in mind, that's really all you need. Now, if we're given these graphs, that can be very easy to see. But if we are not given these graphs, and we are asked a question about, is f of x increasing or decreasing at -1, we need the first derivative of f of x. If we are asked about the concavity of f of x at x equals -1, almost feel like I wish I had subtitles, so you could see how carefully I'm trying to speak. If I want to know the concavity of f of x at x equals -1, I am going to look at the value of f double prime of x at x equals -1. So this is all you need to write. But if we didn't have this graph, right? And again, this graph, very nice. You've seen it 1,000 times. Let's just say we weren't given a graph, but we were asked, and I won't use -1, I'll use a different point. No, I'll use -1. Is f of x equal to x cubed minus 4x increasing or decreasing at x equals negative 1. And let's just say I couldn't figure out how to graph that. Let's say I didn't have a graphing calculator. What would I do? Again, I already know my f prime of x is that. So all I would need to do is do f prime of negative 1 equals 3 negative 1 squared minus 4, order of operations 3 times 1 minus 4. 3 times 1 is 3 minus 1, negative 1. And then again, I would literally, you can just copy and paste. Ugh, I keep on mixing up what color pen I want to use. This over here. All right, f of x is decreasing at x equals negative 1 because f prime of negative 1 is less than 0. So again, I took my derivative, I plugged in where x equals negative 1. I don't even care if that's negative 1, that could have been negative 50. All that matters is that f prime is negative. That tells us that f of x is decreasing. Same thing for the second derivative. Right? If we encounter the question, what is the concavity of f of x at x equals negative 1? Same thing, f prime of negative 1, again, this is a very easy function. 6 times negative 1 equals negative 6, which is less than 0. And again, I'm just going to take this over here. F of x is concave down at x equals negative 1 because f prime of negative 1 is less than 0. This is all you would, for my class, I can say this. For my class, I really want to see the written proof. On the AP test, that's all you really need to write. To my recollection of the scoring guides. But this is absolutely going to be a question on your requiz. This is all the work that you need to do for the homework. Let me just run through another example. You can log off now if you feel like you got it. F of x equals, I don't know, negative 3x squared minus 6 plus 6x minus 7. And the question is f of x increasing or decreasing at x equals 2? And what is the concavity of f of x at x equals 2? Right, 2 questions. And again, I need you to know how to answer these questions. All right, first thing I'm going to do just to get out of the way is I'm going to do my derivatives. F prime is negative 6x plus 6. F double prime of x is negative 6. All right, let's just do this one a little bit quicker. F double prime of 2 is just negative 6, which is less than 0. So, and f prime of 2 is negative 6 times 2 plus 6 equals negative 12 plus 6 equals negative 6. So both at x equals 2, f prime and f double prime are negative. But let's just see how carefully we have to glue all that information together. F of x is decreasing at x equals 2 because f prime of 2 is less than 0. I don't even care what f prime of 2 is. All I care about is that the value is less than 0, right? Or negative. F of x is concave down at x equals 2 because f double prime of 2 is less than 0. So again, very mechanical writing. decreasing or increasing of a base function is always connected to the signage of the first derivative. The concavity, concave up, concave down, is always connected to the second derivative. All right, your homework will look like this.